In this sufficiency question, there is a drawing that represents a triangle, some information confirming that segment AD equals in length segment BC. You have here angle X, angle 2 times X, and that's it. You're supposed to find the measure of this angle. Would it be wise to go directly to the statements to see what information we can obtain from them? Well, you know, a valuable lesson we can learn from this question is that the information that appears prior to the question is not always what simply meets the eye. There might be some hidden information that is not apparent. All that this diagram seems to contain is just what is written and this information that we have represented doing these markings on the drawing. But is that all the information that really exists in this diagram? Not at all. You need to consider that using properties of triangles, you might be able to see deeper inside this diagram, and so conclude that there are some other facts that you can use together with statements 1 and 2 perhaps. What other information exists here that is not apparent to the eye? Let's see. Let's use a little different color in order to make this evident. Take a look for a moment at this triangle only, the one I'm shading. Triangle ABD has one vertex with a measure of x degrees, this interior angle above. But on vertex D, the measure of the exterior angle, that is this, is 2 times x. What if we apply the property of the exterior angle? If we apply the property of the exterior angle, then this angle BDC must have a measure that equals the sum of this and this. So vertex or angle BAD plus the measure of angle ABD. So what is this? 2 times x. What is this? ABD, x. So what is the measure of angle BAD? If we do a simple subtraction, this measure should be x2. In other words, this is x, according to the property of the exterior angle. If we focus our interpretation around vertex D. Okay, if now we know that the two vertices, this one and this one, in this triangle ABD are the same measure, then an important consequence follows. Triangle ABD must be isosceles. Remember isosceles triangles? These are triangles that have two equal interior angles and also two equal sides. So, if these are the two equal interior angles, the sides that are opposite to those equal interior angles must be equal in length too. So, this one here, AD, must be equal with this here. The two sides are the same in length. We know that BD equals AD, and at the same time we know that AD equals BC. So if I put together this and this, what follows? That BD and BC must be equal as well. These two sides are the same in length. But if now we turn our attention on the triangle that is on the right side of this drawing, on this triangle, if two sides are the same, then it follows that the triangle is also isosceles. But if it is isosceles, it must have two equal interior angles as well. What are the two interior angles that must coincide in measure? The two angles that are opposite to the two common sides. So on this vertex C, the interior angle should be the same as this one, 2 times x. And that's it. Now we have some more interesting information prior to the question without even considering the statements at all. Be careful about that. So now we go confidently to statement 1. Statement 1 says that D is the midpoint of side AC. So if this point here is the midpoint of AC, that means that DC and AD should be the same. AD equals DC. But if AD equals BD, AD equals BC, and AD equals DC, then it follows that these three sides are the same too. BD, BC, and DC. If on this triangle BCD, the three sides are the same, then the triangle is not only isosceles, it is equilateral. And if it is equilateral, then it follows that the common interior angle has a measure of 60 degrees. Statement 1, sufficient. What about statement 2? Statement 2 says that the angle ABC is a right angle. What is angle ABC? Start from A, go to B, and then C. This angle here is a right angle. But if that is a right angle, then we know that this angle here and this angle here, they have a sum of 90 degrees, because together with this angle, they should add up to 180 degrees, right? So from this, you can also gather what is the value of x. The two statements are sufficient on their own. But hardly we can say that using the information in each statement, you can just answer the question. It's not just the information in each statement. It's the information in each statement combined with all the information we were able to analyze applying properties. Okay? So be careful with diagrams in a data sufficiency question. Usually, there is more information hidden there than meets the eye.